Hello, everyone. It's Lincoln Fuller and Baofan. We'll be presenting our project title, Predicting Titanic Survivals Using Machine Learning. This project is based on Kaggle competition, where the goal is to use real Titanic passenger data to build a model that can predict survival outcomes.
Some background on the RMS Titanic, commercial cruise liner. It took its maiden voyage from Southampton, England to New York City. And on April 15th, 1912, it struck an iceberg, and about two-thirds of the passengers, crew members aboard died, marking it one of the deadliest commercial tragedies in times of peace.
Project overview. This project is based on Kaggle's Titanic machine learning competitions. The idea is to take historical passenger data and predict who survived the disaster. We explore features like age, sex, ticket fare, and passenger class to build our models. We use four different supervised learning models and compare their performances to see which one gave the best results. And this is our timeline on how we plan to do our project. As a team of two, Lincoln was in charge of data preprocessing, feature engineering, while I contribute more on data visualization and exploratory analysis. We both collaborate in model building, testing, and final evaluation. Data use. The dataset came from Kaggle and include two CSV files, one for training and one for testing. We dropped columns that didn't help much with prediction, like names and ticket cabins, numbers, and BART. We focus on features like age, sex, passenger class, net plus one, parts, and fare. For preprocessing, we handle missing values, use one hot encoding for categories, and scale the numeric columns. Tools and technologies. We use Python as our main programming language. Libraries like Pandas and NumPy help with data handling, while sklearning was used for the logistic regression and random forest models. For the neural network, we use Keras with PyTorch as a backend. We also use Matplotlib and Seaborn for visualizations.
All right, so some of the like before we get into the models, it really helps to look at the data itself and try to make sense of it before you really, start preparing the models that you're going to implement. So this is a good example of it. We looked at the passenger class and sex as it relates to survival rate, and as this graph shows, there's a between both passenger class and sex and survival rate. As you can imagine, historically, women and children were going to be the first on the lifeboats, and a lot of the men were typically going to go down with the ship, or at least more higher prevalence of it. And then passenger class, if you were in first class, you were typically located towards the top of the boat or above the deck rather than below deck. And you can imagine how that might impact your survival in the instance of the boat is sinking. So some of the machine learning models that we incorporated, we based a little bit of this on what we learned in class and also what we learned as we were exploring Kaggle and all the resources that provided. So we wanted to do something simple at the start and implement a logistic regression model, just to kind of get a baseline for what to expect. When we were looking at a lot of the resources that Kaggle provided, random forest, seemed like a popular algorithm to implement. We also wanted to implement a neural network because of lecture information that we wanted to utilize. And as we move forward, there was a lot of information about ensemble or blended models using a little bit of both from Kaggle. So we wanted to do something like that, and we implemented a neural network blended with a random forest model. Overall, our main metric that we used for our analysis was accuracy. We helped this EDA with confusion matrix and classification reports. And overall, what we really saw with this was that, all the different models that, they achieved the similar scores. And that's kind of what we saw throughout the class as well. Our best model, which was the neural network and random forest ensemble algorithm, achieved just over 78% accuracy. And here we can see some of our submissions. Now, the Kaggle leaderboard works as a rolling leaderboard, and you can submit up to 10 entries per day. So this is just a snapshot of a few, notably our highest performing model and then a few others, but we made a ton of submissions overall. Here's our confusion matrix to get a good visual on how our model performed, at least on the training aspect of it. So we wanted to show a little bit about the blended model itself, as that was the most accurate. And you can see there is a little bit of a class imbalance. Obviously, with the Titanic, we noted that about 2/3 of the passengers and crew members died. So that will certainly have an impact on some of our precision and recall scores. You'll notice for 0, which is did not survive, and 1, which is did survive, our recall had a higher accuracy for did not survive. And then for did survive, which there are less total outcomes of it, we weren't, for recall, how many positives do we accurately predict, whereas precision was pretty balanced overall. Um, of our overall positive predictions, we got that pretty right, but we didn't get all of the positives of true survival or non-survival as close. So some of the key takeaways, as we saw, a lot of the models achieved similar scores, and we noticed that we did a lot of the same pre-processing for each model. So oftentimes it's all about the data, and how you can wrangle it, how you can tune it, and manipulate it, because real world data is often very messy and requires, thoughtful and creative handling to achieve what you want. And also at the same time, simpler models can perform well. You don't have to always be complicated, and it always is good to have a baseline as well. And we certainly learned the importance of collaboration. We had a lot of sub deadlines leading up to the final, and we wanted to make sure that we were hitting those deadlines, also maintaining a workload between partners. And overall, if you collaborate well, you can often expect better results than when you don't. So we were happy to learn kind of the ins and outs of that and implement it in our own project. For future work, since it is all about the data, there's some things that you could incorporate that we didn't so far. A lot of things we were seeing on Kaggle that we could employ would be creating a feature called family size, and you basically take the sibling and spouse number and then the parents and children and combine that. Um, you get a couple percentage points boost in accuracy, and then just overall hyperparameter tuning. That's kind of the name of the game too with these machine learning algorithms. And also you want to try out some other ones and see how they compare with what we've done so far. Thank you for your time, and that is our presentation.